Hello and welcome. My name is Martin Pavlovic and this is the presentation of my portfolio project in Cisco Packet Tracer, showcasing my knowledge from CCNA. For the topology overview, we have network design. This network design is a three-tier LAN design. We have access, distribution, and core layer. We can see that we have two layer 2 switches on access, two layer 3 switches on distribution, and two routers on the core layer. For the redundancy, we can see that we have a lot of connections between switches and routers. If any of devices fail, there is always the connection to the internet, to the WAN, to the outer network. So if this switch fails, we have always connection through any other device. We have two VLANs on this topology. This is the VLAN 10, this is VLAN 20 side. So if we send packet from PC 0, it will go to the switch 1. From switch 1, it will go, if this connection is up, it will go to this layer 3 switch 1, and it will load balance on both router 1 and router 2 to the outer internet. So for the first packet, I think it will go to the route 1 and then to the outer network. Same thing is for the PC1 that is in VLAN 20. It will go to the switch 2, to layer 3 switch 2, to router 2, and to the outer network. So for both of our VLANs, we have their respective IP address. So for VLAN 10, we have 192.168.10 and within that network. And for VLAN 20, we have 192.168.20.x in their network. So for the VLAN design, we have 4 VLANs. For the right side, we have VLAN 10. For the left side, we have VLAN 20. For IP phones, we have VLAN 50 or voice VLAN. And for any other traffic, we have VLAN 99 or native VLAN. We have VLAN 99. So for spanning tree, we have every spanning tree configured for every VLAN. So for VLAN 10 and VLAN 50, the main switch is layer 3 switch 1. So it's respectively in his line. And for voice VLAN, it's also layer 3 switch 1 as a primary. As a secondary is layer 3 switch 2 for VLAN 10 and VLAN 50. So if this switch fails, this one will become the root switch. And priority on access switches is maximum cost, so they will never become the root switch, and it won't send traffic to them. For access switches in this spanning tree topology, we have on end devices and ports for end devices. We have configured the port fest and the BPD guard. So if a foreign switch is connected to that port, it won't affect. It will shut down and won't affect the spanning tree topology that we have configured. And we can see that for the Ether channel, we have connected 4 interfaces between layer 3 switches. They are connected with LACP and they can load balance between them. So Switch 1 is actually the active one, and switch 2 is the passive switch. So for HSRP, we have two groups configured. One group is for VLAN 10, the other one is for VLAN 20. The main switch for VLAN 10 is switch 1, and for VLAN 20 is switch 2, with default priorities of 100 as main switches. The standby switches are configured with priority of 90, so if one switch fails, the gateway to VLAN 10's hosts will go to switch 2. Same goes for switch 1 and for VLAN 20. We have configured preempt on both main switches for different VLANs. So if this switch fails, this switch 2 becomes the active switch, and if that switch comes, and if switch 1 comes back for VLAN 10, they will be active again for the as a main switch for gateway. So for OSPF, we have configured everything on area 0. We have router 1, router 2, layer 3 switch 2, and layer 3 switch 1 with their routers ID being for router 1 being 1111, for router 2 being 2222, for layer 3 switch 1 being 3333, and for layer 3 switch 2 being 4444. We have passive interfaces on switches, so they don't send OSPF LSA packets to this to the access layer switches, so they don't need those packets. So interfaces facing the hosts, they are connected, configured with passive interfaces for the OSPF. We have also configured static routes on layer 3 switches, so we know how to get to the router 1 and router 2, and also in between routers with layer 3 switches. So if we ask for a DNS name for DR1, we actually have the router ID on the as a domain name IP address for router 1, and we have configured on every switch passive interface, loopback interface. I'm sorry. So router 1 has actually the 1111 loopback interface configured on it. Same goes for router 2. Same goes for switch 1 and switch 2. So the static routes are there for reachability and management and testing purposes. So on router 1 and router 2, we have configured NAT overload. So when someone from inner LAN tries to connect to something outside this network, it will go through those routers and it will go through NAT overload. So it will change the inner IP address to the public IP address that is configured on R1 and R2, but because it's not overload, it will be connected via ports. So if we have this PC 0 trying to reach out to DNS server, we will do like 192.168.10, let's say 5. On port 1050, let's say, and it will go to this net. So if we see the packet on the outside network, it will say 2030.16.1 with the same port as the previous address, so it will be 1050, and we will see the outside local and outside global of, or if we try to ping DNS server or reach out to DNS server, we will see 8888 with outside and inside global being the same, being on port 53. They are both connected, they are both configured for both VLANs and VLAN 1 and VLAN 2, so if same happens on PC1, it can go through router 1 and go to that route on switch for on WAN router or outside network, and it will know how to where to send back that packet because of that NAT overload and connecting them via ports. For the DHCP servers, we have configured both routers with DHCP. So for VLAN 10, we have configured it on router 1, and for VLAN 20, we have configured it on router 2. We have DHCP relay configured on the loopback address on SVI, VLAN SVIs on layer 3 switches, and with helper IP addresses going through their respected router. So if I ask from PC0 to give his IP address to the R1, it will actually go to switch 1, then switch layer 3 switch 1, and go directly through R1, getting its IP address related to the VLAN they're in. It will go back, and there will be the DHCP server actually working, and the PC0 will have his IP address. I can actually showcase that with IP config. So now we have 192.168.10.5 configured on this PC. So if we go IP config release, this releases the their configurations from the IP from the PC, from the DHCP server, and you can see the DHCP server actually provides IP address, subnet, default gateway. That this gateway will be in related gateway to VLAN 10, and the DNS server that is in outer network. So we will do now renew. So we will get from DNS server the new IP address. It's probably going to be the same IP. Oh, it's not. Okay. So you can see that now it's 192.168.10.4. It was actually, you can see here 192.168.10.5. Now it's in now you can see that is 192.168.10.4. We got the subnet mask that is /24. We have default gateway that is related to the VLAN that this PC is in, and we have DNS server also. We can do the same in PC1. So if we go command prompt ipconfig release and renew, we can actually see that the the IP addresses in its related VLAN. Same goes for the default gateway. So the DHCP server works on both routers and both PCs, of course. So for the security, Telnet is disabled on every single device. Every single device uses SSH. So but you can only connect from PC0 or hosts on VLAN 10 to. You can only connect to switch 1. That goes same for switch 2. You can only connect to switch 2 with VLAN from hosts on VLAN 20. So if we go and try to connect like SSH from PC0, so that is in VLAN 10, you can actually see that we can. So this is the IP address for VLAN 10. For VLAN 10 and for layer 3 switch 1. So it will actually connect and ask for the address, and here you can see that we have connected to the layer 3 switch 1. You cannot connect to this switch with the other from VLAN 20 because you have I have configured the access list in this on this router, so you can see that extended IP address access list block SSH VLAN 20. So any device in this network cannot connect with VLAN with SSH. So and every other connection is up. Same goes to VLAN. Same goes to other switch. You cannot connect with this PC that is in VLAN 10 to the other switch. So we can try that SSH. So we can try to connect with this PC onto the switch 2. So you can see the connection is refused by the remote host. So the same thing is connected. So the same thing is configured on the layer 3 switch 2, but with only block SSH VLAN 10 and different network group. Here is changed only to 192.168.10.0. So any device from that network cannot connect with SSH to layer 3 switch 2. So for switch 1 and switch 2, we have port security, we have DHCP snooping, we have dynamic ARP inspection. I can showcase the port security on both switches. We have maximum sticky MAC addresses, one for IP phone, the other one for PC. One, it's in restrict mode and it will wait the 5 minutes to actually clear the MAC address sticky. I can now showcase. I think that we have now violated the security for port security. So if we go into it, we can enable it and clear port security MAC address port security sticky like this, and this command will actually clear the MAC address, the port security MAC address table. So when we do this and go for a ping on any device, you can actually see the first ping will probably fail because of that switch, and we will no longer get the and we will no longer get, okay, we don't even get the first even the first ping doesn't fail. So we can see now that show port security. Let's see address. You can see that one is for IP phone, the other one is for the PC. So for the DHCP snooping, the trust ports are ports towards the routers. So any other interface that is getting the DHCP, that DHCP message that is not those for interfaces facing the routers will be dropped, and any other from any other interface that is being used for the hosts will be marked as untrusted. Here we have also configured the option 82, so if we send this if we send from PC0 and asking it for the R1 the DHCP message, it will be dropped here because the switch 1 is actually thinking that the next hop will be the DHCP server, so the switch 1 getting the DHCP message will think that is untrusted and it will be dropped. So for the last device we have DNS server. On this DNS server we have actually configured multiple domain names. We have for both routers and for both layer 3 switches configured with their loopback addresses. We actually have this test ping. This test ping has a loopback address from the WAN router, and we have this DNS domain name with the DNS IP address. So we can actually test this if we go into PC1 and if we ping and go to the simulation actually to show you where the packet actually goes. And if we ping R1 for the example, we can actually start. You can see that there is the packet. So let's start the simulation. It should go to switch 1, it will go to layer 3 switch 1, and from there on it will load balance between those four devices. So you can see that the domain name of router 1 actually goes to the DNS. DNS brings back the IP address from the domain name R1, and now we should actually get the IP address. Now you can see there is the IP address, and this is we are following now the ping for the packet of ping towards the R1. R1 receives it, brings it back, and that should be it. The DNS works, so it will show now. Yes. So we asked DNS server the IP address for this R1. The DNS server brings us this IP address related to R1. We tried using that IP address for ping, and we actually got the and we actually got the answer from router 1. So that was my Cisco Packet Tracer portfolio lab. I learned networking from zero, directly through CCNA books and from Jeremy's IT's labs. Also, NetSim and XSIM also helped me to learn networking from scratch. It took me 6 months to actually finish CCNA, so everything that you see here was made from scratch, and I hope that you enjoyed. And thank you for watching, and see you next time. Goodbye.